All right, guys, we're going to take another look today at probability. Now, last time we got together, we talked about probability of simple events. So you flip a coin, and what's the probability that it shows heads? Well, the coin has two sides. One of them was heads. So the probability that it showed heads was 1 out of 2, or 1/2, or 0.5, or even 50%. Today we're going to talk about probability of compound events. So a compound event just means that there's more than one thing happening. It's not just flipping a coin. Maybe you're flipping a coin twice, or maybe you're flipping a coin and rolling a die. Now the catch is sometimes you talk about independent compound events and sometimes you talk about dependent compound events. We're going to focus mostly on independent events. Independent events are events in which the outcome of one event does not affect the probabilities for the second event. Okay? The probability of that first event has no effect on the probabilities for the second event. So think about flipping a coin. You flip a coin 2 times. First time it shows heads. Does that affect what's going to happen on the second coin flip? Not at all. Okay, those are independent events. Then we talk about dependent events. Now we'll get into these a little bit later. I just want you to have an idea of what they are. Dependent events, well, if independent events are events in which the outcomes of one event do not affect the probabilities of the outcome of the second event, dependent events would be events in which the outcomes or the outcome of one event does affect the outcome or the probabilities for the second event. Okay, that would be dependent events. So we're not going to worry too much about these. We're going to focus primarily on these independent events. That's what we're going to look at mostly. Every once in a while we'll get into some other stuff, but for right now we're going to focus primarily on these. So, a probability of 2 independent events. Now remember, we said that we use this symbol, we write it like this. If I want the probability of something, I put a capital P, open up the parentheses, and say what those things are. So let's say probability of A and B. So there's 2 things. I want to find the probability that both of those things happen. Maybe I flip a coin 2 times. First time it shows heads, and the second time it shows tails. That's what I'm looking for here. Well, what I can do is split this up. I can find the probability of that first event. I can find the probability of that second event, and I can multiply those together. And that's all there is to it. So let's go with that coin flip example. Let's say I want the probability that I flip a coin 2 times. First time it shows tails, and the second time it shows heads. Well, what I'm going to do is separate. Find the probability of tails on the first flip times the probability of heads on the second flip. Well, the probability of it showing tails is 1 out of 2, or 1/2, or 0.5. And the probability of it showing tail or heads on the second flip would be, again, same thing, 0.5. And I'll multiply those together, and the probability of it showing tails the first time and heads the second time is 0.25, or 25%. Okay? Now that was a real simple one. Let's take a look at a couple others. Let's take a look at this first example here. So there's a bag with green marbles, 5 green marbles, 3 yellow marbles, 2 purple marbles. You randomly select one marble from the bag, replace it, and randomly select a marble again. What's the probability of selecting a purple marble and then a green marble? So we want to find the probability of a purple marble and then a green marble. Well, let's take a look at this bag. Okay, so here's my bag of marbles. And in this bag of marbles, there are 5 green marbles. So 1, 2, 3, 4, and 5 green marbles. I have 3 yellow marbles. 1, 2, 3 yellow marbles. And I have 2 purple marbles. 1 and 2 purple marbles. Now I want the probability that I get a purple marble and a green marble. So this would be equal to the probability of a purple marble times the probability of a green marble. Well, for a purple marble, the probability that I get the purple marble from the bag. So look at this bag. How many of these marbles are purple? Well, there's 2 of them. Okay? Out of how many total marbles? Well, I've got 2 plus 3 more yellow ones, going to give me 5, plus 5 more green ones gives me 10. Okay, now that's the probability of the purple marble. Now what happens is I put that marble right back into the bag. So nothing's changing. I'm drawing from the same bag again. Shake them up, and I'm going to randomly select a marble again. What's the probability that it shows a green marble this time? Well, look at that bag, and we said there are 5 green marbles out of the 10 total marbles. So what I can do with fractions is I can simplify these first. I can say 2 out of 10, 2 tenths, reduces down to 1/5, and 5 tenths reduces to 1/2. And then I multiply those together. 1 times 1 is 1, 5 times 2 is 10, and the probability of drawing a purple marble and then a green one would be 1/10. The probability of selecting a purple marble, then a green marble, is 1/10. Okay. All right, let's look at number 2. Number 2, you flip a coin and roll a fair 6-sided die. What is the probability that the coin shows tails and the die shows 3? So I want the probability that the coin shows tails and the die shows a 3. That's what I want. So that's the notation that we'll use. P of T and 3. Now what we can do is separate. And I can look at the probability just that the coin shows tails, find the probability that that die shows a 3, and then I can multiply those two. Okay, well think about a coin flip. The probability from any fair coin that you flip it and it shows tails is going to be 1/2. Okay, and then we want the probability that the die shows 3. Well, think about that die. Think about a 6-sided number cube. There's 6 sides, and only one of them is 3. So I have 1/2 and 1/6, and we're going to multiply those. And if we multiply straight across, 1 times 1 is 1, 2 times 6 is 12. So the probability that the coin shows tails and the die shows 3 is 1/12. The probability that the coin shows tails and the die shows 3 is 1/12. And there we go. All right. So those are 2 pretty basic ones. Okay, you've got the bag full of marbles, you got the coin and the die. We want the probability that we get a purple marble and then a green marble. Probability that we get a tails and then we get 3. So all we have to do is split it into the individual pieces. Find each individual probability and multiply those together. Now remember, if you're dealing with fractions, it's a good idea to simplify where you can. If you can simplify it, it's going to make your job a little easier. Rather than multiplying 2/10 times 5/10, 1/5 times 1/2 gives you some slightly smaller numbers to work with. It's going to make your job a little bit easier. You don't have to simplify at the beginning. You can do it at the end. Just make sure you simplify the fractions when you can. Okay? Now, let's take a look at the back. You got a couple more there. All right, so this time, you roll two distinct dice. One blue one and one red one. We want the probability that the blue die shows a 2 and that the red die shows a 4. So, I want the probability that the blue die shows a 2 and that the red die shows a 4. So we're going to split this up. And we're going to look at the probability of the blue die showing a 2, the probability of the red die showing a 4, and then we're going to multiply those two. Okay, well, think about this die. It's a fair six-sided die, regular standard die, which means that it has 6 sides. So that's our possible outcomes. How many of those possible outcomes are a 2? Well, if it's a fair die, only one of them. Okay, so then we take that 1/6, and we're good with that. Now think about the red die showing a 4. Well, again, it's a fair six-sided die. How many of those 6 sides are 4s? Just one of them. And then we multiply those two fractions together. And when we multiply straight across, 1 times 1 is 1, 6 times 6 is 36. So, the probability that the blue die shows 2 and the red die shows 4 is 1/36. The probability that the blue die shows 2 and the red die shows 4 is 1/36. Okay? And there we go. So it's pretty simple. We separate it into the two different pieces, find each individual probability, and we multiply them together. Now number 4 is really similar. Okay, we've got the same two distinct dice, one blue, one red. We want the probability that the blue die shows 2 and that the red die shows a 4 or a 5. So this one's going to be a little bit tricky, but not that bad. So again, we're looking at the probability the blue die shows a 2, but this time we want the red die to show either a 4 or a 5. Either one of those would be counted as a success. So what we can do is separate them. Okay, we can split them right down through this and we can look at the probability of that blue 2 and the probability of the red 4 or 5. And once we have those two, we can multiply them together. Okay, well, the probability of that blue 2, we already said before, is going to be 1/6 because the die has 6 sides and only one of them is a 2. Okay, then for this red die, well, it still only has 6 sides, so it's still going to be out of 6. But how many of those spaces are a 4 or a 5? Well, I've got one side that's a 4, and I've got one side that's a 5. So that means that there's 2 sides that would make me happy. 2 sides that would be counted as success. So the probability of a 4 or a 5 is 2 out of 6. Okay, now what I could do here, and what I will do here, I'll keep this 1/6, but this 2/6, I'm going to reduce that down to 1/3. Okay, and we said what we need to do is multiply those. And when we multiply, the fraction straight across, 1 times 1 is 1, 6 times 3 is 18. So we can say the probability that the blue die shows a 2 and the red die shows a 4 or a 5, is 1/18. Okay, the probability that the blue die shows a 2 and the red die shows a 4 or a 5 is 1/18. Okay, and there we go. That's all we have to do. Split it into the two events, find each individual probability, and multiply them together. Now, something I want to point out here. Look at the difference between these two probabilities. We have 1/36 and we have 1/18. Now, 1/36 has a larger denominator, which means that the total fraction is actually smaller. If we go to a calculator and we do 1 divided by 36 to get our decimal, this would be 0.027 repeating. And over here, if I do 1 divided by 18 to get our decimal, this would be 0.05 repeating. Now, we can see, guys, that this 1/18 is a larger probability. Why would it be larger? Why would it be a greater probability if I have two different options? Well, think about what we said. Our successes is if what we want to happen, happens. All I have, the only thing that's going to be considered a success for this red die on example 3 is just the 4, which means it's 1 out of 6. But for this red die, the 4 or the 5 would make me happy, would be counted as a success. Which means that that probability is double. I have twice the possibility for success on the red die on example 4. So that's going to increase the probability here, which is going to increase the probability here because they're the same number. And when you multiply by a larger number, you're going to end up with a larger result. So because we have more things considered a success on example 4, we have a greater probability of success for our final answer. So like we said, though, it's all going to come back to the same thing. If we have the probability, if we want the probability of two compound independent events, we're going to find the probability of each individual event and multiply them together. And that's really all it's going to come down to.